my great pleasure to have an opportunity to talk to you. My name is Manak Nakano, and I'm researcher at the IPA. Today, I'd like to talk about approach for connected vehicle security. And here you can see what I'll cover in my presentation today. So, as you know, the environment surrounding cars has been changing dramatically in recent years. A car can be connected to the internet through smartphones, and the use of open protocols such as TCP/IP is under discussion. Also, as we can see in the emergence of electric vehicles and car sharing service, the way we live with cars is changing. As all these trends push people to be more intelligent and process more information, people are about, if not already, to fight the threats of cyber attacks. To use car safety, the security, it is necessary to analyze security vulnerabilities in vehicles and take countermeasures and develop secure vehicles based on the analysis. IPA conduct security analysis and promote vehicle security in Japan. Before we talk about vehicle security, let me introduce IT Security Center report. So, IPA Security Center has following 5 missions: information security, vulnerability mitigation, and virus mitigation, and unauthorized access prevention, and so on. And as our output, we publish the report and develop security tools. In particular, recently more and more, if not all, devices are connected with internet. So I'm concerned that more threats will be beginning to emerge everywhere. That's why IBM has been researching embedded system security since 2006. And since 2008, we have been conducting studies, especially in vehicle security. We release annual report and all vehicle security seminars. We have to examine vehicle security with many experts. Today, I'll talk about our proposal in vehicle security based on our findings. IBM analyzed security issues in vehicles from 2 particulate in approach for vehicles information security. One is what kind of attacks and countermeasures for vehicles are feasible. And second thing, the other is how to approach the security in vehicles life cycle. I'm going to answer these 2 questions. First, we analyze the vehicle security in such flows. The first, organization things connected with vehicle, and second, analysis of function of the vehicle. Third, organize information in the vehicle, and fourth, analyze vehicle threats. And finally, study countermeasures that can be used in the vehicle. So, we have to organize anything that could connect to the vehicle. Vehicle connect to any service and devices, and attacker and malware could appear in various places. When the development of technology, it is possible to connect shall not be assumed at present. We classified vehicle system into components for threat analysis. Then we identified these approaches that could be used by malicious attackers to exploit vehicles' vulnerabilities. Firstly, proximity attack. In this case, the attacker themselves directly and physically attack a vehicle by pressing something or playing some tricks. This approach may be taken widely in the case where a single car is used by a lot of people, like car sharing. Secondly, immediate attack. Carried in device like smartphone and infected with malware and used for attacks in these cars. If the use of open or standard protocols become popular to enable communications between the vehicle and carried-in device, there is a possibility that on-vehicle systems get infected with malware through those carried-in devices. And thirdly, network attack. It's where attackers attack a vehicle through communication network. As networking between in vehicle network and external network expands, there is a possibility that a vehicle may be cyber attacked even when it's moving. First of all, it's important to think about where attackers may be coming from. Next, IPS thought about what kind of attack against car could be possible. To tackle this issue constantly, it is necessary to define the structure of a car. To classify the functional of a typical car, IPA made up a hypothetical car called the IPA car. IPA car has the functions classified in three groups. Basic control functions related to the vehicle's basic driving capability, and extended functions that supported its driving capability, and common functions that the device using by connection to the vehicles, and organizes the roles and such each function. So, the basic control function are most essential function for a car, and control the car to move, turn, and stop. The ensure the safety of the driver, we believe they must be most secure. When an attack is detected with the extended function or common functions, it is necessary to cut off from those functions somewhat, for example, using a firewall. And next, so extend functions is extend functions support the movement of the car and offer the comfort and convenience of driving to the driver. To do that, they may use road-to-vehicle or vehicle-to-vehicle communication or other external communications such as GPS. As IPS develops future, various changes will be made and new security technologies may be required in the future. And the common function are the devices that driver carry into the car, such as smartphones and PC. Since they are likely the off-the-shelf products, they are easy to attack and will be likely target of attacks, because it is difficult to vehicle manufacturer to take care of the security of those devices. It will be the driver's responsibility to take necessary security measures. Next, we classify the object to protect. It is important to understand that what you want to protect from the attacker. In information systems, the most important is confidentiality in most cases. But in vehicle systems, the most important is availability. Safe stop is required in any state, and it is must be protected by top priority, the basic control function. Okay. Next, the failure is the result for the threat analysis based on our approach. The result shows that vehicle would fact the some threats as PCs. Not only the carry-in devices that are functional similar to PCs, but also the ITS function and telematics that can connect the external network may be attacked. On the other hand, the basic control functions related to the vehicle's driving capability has little risk of being attacked directly. Yet, the study suggests that it is possible to attack them through other functions of the vehicle. It is necessary to take appropriate security measures against these threats. So, how will implement the security measure? I thought the effort of two ways. First, we consider the common security technology in the information system for vehicle security. We can use many knowledge of information system securities, and the security measures were not effective in information system, but may be effective in the vehicle. And next, study of security that specialize in vehicle. Some professors and researchers have started working on these vehicle security measures. I hope that will be discussed activity for vehicle security at a conference like this. And another technique we have summarized the need to consider security in vehicle development life cycle. Development life cycle is into four phases: planning, development, operation, and disposal, and should be carried through while management. We concerned measures that should be implemented in each. For example, handling security issues in operation phase, we are create a system which can respond properly when the vulnerability information was delivered from the user. I don't have any time to talk for more information of this, but I bring the book of this approach like this in Japanese version and English version. Please contact me after the session if you are interested. I am present these books, and don't worry, it's free. In order to vehicle-related organizations working on security, we divided level 1 to 4 based on awareness of security, whether the security rule in the organization and structure of the organization. So we want to use this approach for security analysis of product and service of their organization and understanding of their organization and recognition of improvement points. I hope this approach becomes the help to consider of vehicle security. Final proposal. The threat analysis of vehicles has only just started. To consider vehicle security, not only vehicle manufacturers, but also service providers and drivers should participate in implementing security measures. IPA plans to keep promoting vehicle security in Japan. Here I'd like to sum up my presentation. Until recently, vehicle safety has been kept by the effort of vehicle manufacturers. But now, many new types of attacks through internet or smartphone are beginning to appear. For example, malicious attackers or malicious software installed in smartphones may attack or impose bad effect on vehicle. However, there are so many types. There are many types of car and various people from various fields implement and car is needed to discuss vehicle security. IPA would like to provide a concept of the IPA cars for that purpose. We hope it will help and forward the analyzed work on vehicle security. Thank you very much for your attention.
Thank you so much.